Hello there. Today we'll be doing number 85. This is called walls and gates. This is an interesting problem. In this particular problem, we have walls, -1, and we have a gate. We're trying to get all our items to go to our gate. This looks a lot better if we use Neetcode, Leetcode, to take a look at the problem. So let's do that. Code, walls, and gates. Let's see. Very good. We have, oh, it's locked. Okay, well, all right. So, yeah, we have Neetcode and it's locked. So, I'm gonna do my best to show you what it means. So at the 0, let's draw it out. So we have 0, we have a -1, and we have some blank items. Let's say inf here, infinite, and infinite here. So in this particular grid, we're trying to find out how long it would take for these items to get to 0. And if we do a BFS, we can move from this direction into this direction, and we can visit everything at each particular interval and give it an appropriate distance. And we would not access anything that has been visited already, and we can move from all directions from each particular gate. And this is very similar to this particular problem here called rotten oranges, where we use BFS to detect the number of how to spread the oranges, but increase the time it takes to determine how long it will take for all the oranges, or for how long it will take for all the gates to populate. So I think this is a very good problem. It's very similar to the orange problem. I think maybe even like if it's basically the same, but we add to the character itself. And I think this will help make our code in the orange problem even better. So of course this takes 1 space and this takes 2 spaces, and if this was a -1, we would basically find that this is impossible, and we would there would be nowhere to go, and we'd be done with the problem. Anyway, sorry. All right, so let's get this on the road. Rows and columns equals length of rooms and length of rooms at 0 distance. So then what we need is we need visited is equal to a set, and we need distance, which is equal to 0 at this point. All right, now we have all of these items. Oh, we need a queue, right? Collections.queue, DQ. Something about this particular thing about we need to add collections. So anyways, def.add rooms. Oh wait, sorry. Okay, so next thing we need to do is to collect all the items into our queue. For j in range, I think we should use R and C. I'm very much keen to use R and C now. It's my preferred method to go through rows and columns rather than I and J. Just looks better. I don't know, it's your preference. So anyways, if rooms at rows and columns at that particular row and column is equal to 0, that means it's a gate. Let's queue.append this particular R and C into the queue. Also, at the same time, visited, because we need to add, we've seen it, so we need to add, we don't want to see it again. Okay, so with that, while queue, we can move on. Yes, so while queue, we want to pop left. So RC equals pop q.pop left. Okay, how much do we want to pop left? So we want to pop left 4 I in range len q, so we don't get any more in this particular layer, and we can add to this queue without worrying about other lists. So anyways, with that done, what we're gonna do is that distance is plus equals 1 now. Okay, what do we need to do with the rows and columns? We need to make sure that we add the additional rows and columns to our queue, but there's a check, and we don't want to repeat all that logic. So what we're gonna do is we're gonna add the rows plus 1 and the column, and we're gonna repeat this logic so that we can like just reduce the amount of code we need to write. Okay, so with that, we have added all the rooms, and we will continue adding rooms until what that does is that we either continue running the breadth first search and adding the items to your queue so that we can process it for the next round or not. So anyways, so we're gonna take the rows and columns. So if a row is less than 0, or a column is less than 0, or a row is greater than or equal to the rows, or column is greater than or equal to the columns, or well, we hit a wall, so we can check if we hit a wall now, or it's in visited. So in visited, and or we hit the wall. Equals -1. So when we return otherwise, visited dot add. We're gonna add our RNC so that we don't visit it again. We're gonna set room.rnc to equal to the distance that we've selected, and we're going to queue.append this RNC so that we can move on from this character onward to another. So with that, I believe we are done with this particular problem. Oh, room is not defined. Let's see. Nothing's looking right. So we have the wrong answer. I wonder what's wrong. Oh, right. This is not supposed to be here. We want to set that here, because this is the particular room that is at the distance, not all the other rooms. Anyways, let's submit. And it has been accepted. So this is how we do I'm choking on water. This is how we do walls and gates. It's a very simple formula, and I think we can go back and fix our rotten orange code. And I will do that now. If you enjoyed the video, like and subscribe. If you want more, check the link in the description below. And without further ado, I'm gonna see if I can correct this. So we can remove all of this code, and we can just can we? Can we do that? Is it possible? Or is it because it's two variables? Let's see. I don't know if that actually works. Aha, it doesn't work. Okay, well, I tried. Unless... Okay, that doesn't work either. Okay, fair, fair, fair. I mean, you learn something every day. So instead of that, I don't think we need directions anymore. We can just throw that into raw directions, oranges, and so far, and so on and so forth. So -1, +1, and -1. And we don't need directions anymore, and we just take that out. OMG, we cleaned up the code. I believe. Huh, fresh oranges? Okay, that did not work completely, but do we still need fresh oranges? Yes, we do. Okay. Non-local fresh oranges. Append R and C. Perfect. Look at this. Perfect. So we cleaned up our code for raw oranges as well. This is much better. This was what I was hoping for when I first solved rotten oranges, and it looks like we got there eventually using this new scheme. Yeah, wonderful stuff. So it's a little different, but I think we should solve it this way first and then like move the logic back in. But anyways, I hope you enjoyed this video. Like and subscribe, and check the link in the description for more. Thank you very much. I'll see you in the next one.